This section has 28 problems, which means I want to do 14 problems right now. If I can do them in 2 minutes a problem, then I can keep this to one video. 3 minutes a problem, I need to do it in 2 videos. So let me start doing my implicit differentiation to find dy dx. The derivative of y squared would generally be 2y. Because I'm finding dy dx, and this variable is not an x, I need to tack on a d that variable dx, which is going to be just dy dx. Then the derivative of minus 2x squared is 4x. I could say dx dx because the variable that I took the derivative of was x, and I'm doing it with respect to x, but dx dx would be equal to 1, so I don't need to write it. To the right of the equal sign, the derivative of 5x is 5, the derivative of minus 2 is 0. This is the derivative. I need to solve it for dy dx. Just takes me 2 steps. I'm going to add 4x to both sides. And this is going to give me 2y dy dx equals 4x plus 5. And then I'll divide both sides by 2y. You can make a big fraction or a small fraction. If you make the big fraction, it can't reduce. So one correct answer for problem 2 is dy dx equals 4x plus 5 over 2y. The alternative would have been on the right-hand side to write 4x over 2y plus 5 over 2y. And if you wrote it like that, you could cancel that 4 with that 2. And an alternatively correct answer would be dy dx equals 2x over y plus 5 over 2y. Both equally correct. I wrote this as my instinctive answer, but wouldn't matter to me if you wanted to do one big fraction or 2 small fractions. The one big fraction almost never reduces. The 2 small fraction almost always reduces. So for 6, let me just plow through here. I'm going to do the derivative of 6y. The derivative of this, since it's the first power term, is just its coefficient. Since I took the derivative of a y with respect to x, I need to tack on a dy dx. The derivative of minus 7x cubed is going to be minus 21x squared. Just multiply the 3 and the 7 and lower the exponent by 1. And then on the right-hand side, the derivative of 5x is 5. I need to do the 2 steps of algebra to solve for the dy dx. So this is going to give me 6 dy dx equals 21x squared plus 5. And then again, I can make a big fraction or small fractions. If I make big fractions, it doesn't reduce. If I make small fractions, it does reduce. The answer that I have typed that you can't see off screen right now because it doesn't fit on my screen is dy dx equals 21x squared plus 5 over 6. The alternative would have been to do 21x squared over 6 plus 5 over 6. And had you done it this way, you can divide by 3. 21 divided by 3 is 7. 6 divided by 3 is 2. So an alternatively correct answer, not any better or any worse, would be 7x squared over 2 plus 5, 6. Both correct. Can generally only reduce if you make this 2 individual fractions. This one can't reduce because if you reduce this and made that 7 over 2, then you've lost the 6 that belongs under the 5. 6 is one where I'm going to get 2 dy dx's and I'm going to have to factor. So on the left-hand side, I'll do the derivative of y squared, which is 2y. Because it's a y, I tack on a dy dx. The derivative of 6y is just 6. Because I'm taking a derivative of y with respect to x, I tack on a dy dx. On the right-hand side, the derivative of 2x squared is 4x. The derivative of minus 9x is minus 9. The derivative of plus 1 is 0. That's the derivative. Now I need to solve it for dy dx. I'm going to pull out a common factor of dy dx on the left side. There is also a common factor of 2, but it probably, if I want to factor it out, would pay off to wait. Now I can divide both sides by 2y plus 6 and get something that's suitable for an answer. And let me see if I can just show my answers up here. So for my answers, I wrote just this fraction, unfactored, and then I factored the denominator. It's probably preferable to factor the denominator, but it's not a deal. Both of these are good enough for answers. Neither fraction reduces. A 2y plus 6 can only cancel with a 2y plus 6. Once there's adding or subtracting between variables, you can't really even make it into individual fractions and reduce. Once there's a plus or a minus in the denominator, you could only cancel with an exact copy. So this 2y plus 6 would only cancel if there was a factor of 2y plus 6 in the numerator. Eight is similar. I'm going to do the derivative of 2y squared by multiplying the 2 times the 2, lowering the exponent by 1 and getting a 4y. I took the derivative with respect to a y, so I'll tack on a dy dx. After the minus sign, there's a minus 1y. The derivative of minus 1y is minus 1. I'm going to tack on a dy dx. To the right of the equal sign, the derivative of 3x squared is 6x. The derivative of minus 5x is minus 5. Now I'm going to pull out my common factor of dy dx on the left side. And when I factor out that common factor, I'm left with a 4y minus 1 for the inside of my parentheses. There's no even common factors here. I'm going to solve for dy dx by dividing both sides by 4y minus 1. And this is going to be the right-hand side of my answer. So I have it typed up here. Dy dx is 6x minus 5 over 4y minus 1. For 10, I have y's on both sides of the equation. I could get the y's to be on the same side of the equations to start if I was clever, but I'm not going to be clever. I'm going to take the derivative of y squared, which would generally be 2y. I'm going to tack on a dy dx. To the right of the equal sign, the derivative of 3y is just 3. I'm going to tack on a dy dx. And the 2x has a derivative of 2. I need to solve for dy dx, which means I need to get the dy dx's on the same side of the equation. I can't have them on opposite sides of the equation. I'm going to get them on the same side of the equation, and I'm going to factor out the common factor of dy dx like I did in the last few problems. So this is going to give me 2y dy dx minus 3 dy dx equals 2. Now I can pull out the common factor of dy dx and get dy dx times 2y minus 3 equals to 2. And then divide by 2, divide by 2y minus 3, divide by 2y minus 3. That will make the 2y's minus 3's cancel on the left side and get a fraction that's not reducible. I can't cancel the 2's here. If it was flipped over and the 2 is in the denominator, I could write it as separate fractions and reduce. And I don't know why I just wrote this twice, because it doesn't reduce, but nevertheless I did. One of those was sufficient. Maybe I'll delete this in the future so I don't have that written down twice. 12 is a lot like 10. I'm going to do the derivatives, subtract, and then factor. So on the left-hand side, the derivative of 8y would generally be 8. I'm doing dy dx, and I took the derivative of a y, so I'll tack on a dy dx. To the right of the equal sign, the derivative of y squared would be 2y. I should tack on a dy dx. The derivative of 2x is just 2. I could tack on a dx, but that's just equal to 1. And the derivative of the minus 1 is 0. Now I'm going to minus 2y times dy dx from both sides. And just because it looks more proper, I'm going to write the 2y term first on the left-hand side, so the variable is written first. So this is going to give me negative 2y dy dx plus 8 dy dx equals to 2. Now I'm going to factor out my dy dx and get dy dx times negative 2y plus 8 equals to 2. That common factor of 2, or potentially negative 2, is actually going to cause this fraction to be reducible. Common factors in front of parentheses can cancel with single numbers in the numerator. I'm going to factor out a negative 2 from my numerator, from my denominator, and get dy dx equals 2 divided by negative 2, and I factor out a negative, I switch the signs. This positive y, negative y turns to positive y, the positive 8 when I factor out a negative 2 turns to negative 4. And now I can reduce this and this. 2 divided by negative 2 is negative 1. I'm going to put the negative in the numerator, and I'm going to write dy dx equals negative 1 over y minus 4 for kind of my best possible answer. Now I need this. So for 14, I need to do the derivative of the xy term. I need to do the derivative of the 6x term, 6x squared term, and I need to do the derivative of the 9x term. This is x times dy dx plus y. Did that on the first video. I knew I was going to need it. This piece is just minus 12x. I could tack on a dx, but that's equal to 1. This piece is 9. I could tack on a dx, and that's equal to 1. So this is important. I would just have this in your notes so you're not creating it every time. Now I need to solve for dy dx. I'm going to minus y and add 12x to both sides. And I like to write the x first and the y second. I'm not sure why, but I do. So the left-hand side, when I do the minusing y and adding 12x, I'm going to get x times dy dx. And on the right-hand side, in any order, but probably having the 9 last would be the best. And now I can divide. And when I divide, I could make a big fraction. And if I make a big fraction, this fraction is not reducible. One correct answer for number 14 is dy dx equals 12x minus y minus 9 over x. The alternative, I could have done 12x over x minus y over x minus 9 over x and made 3 individual fractions as opposed to the big fraction. And if I did that, the first fraction would reduce. An equally correct answer would say 12 minus y over x minus 9 over x. I couldn't just reduce the x in the big fraction because the x needs to stay under the y and the 9, but I could make individual fractions if you care to. They're both equally correct. So 16, I'm going to start, it's 2 dy. I might just do this derivative then. Let me find the derivative. In fact, let's do 15 together. That says 115 for some reason. Let's do 15. Let me find the derivative. Derivative off to the side of 5xy. I'm going to need the product rule because of the multiplication. So I'm going to have the first factor is 5x. The second factor is y. The derivative of the first factor is 5. The derivative of the second term, because it's a 1y to the first power, is 1 is the derivative of y to the first power. Tack on a dy dx. cross multiply, the derivative is going to be 5x times 1 dy dx plus 5y. And I'm not going to pull out that common factor of 5 because it's not going to help me here. So as I go to take this derivative, the derivative of 5xy is 5x dy dx plus 5y for the derivative of the first term. The derivative of the minus 3x squared is minus 6x. The derivative of the 5x cubed is 15x squared. So now I've found the derivative, I just need to solve it for dy dx. I'm going to minus 5y and add 6x to both sides. And I'm going to do the 6x first and the 5y second. This is going to give me 5x dy dx equals to 15x squared plus 6x minus 5y. And if I big fraction divide, it won't reduce. If I small fraction divide, I can do some reducing. So one proper answer for number 15 would be dy dx equals 15x squared plus 6x minus 5y, and that numerator doesn't factor. There's no common factor I could factor out. That would be a correct answer. The alternative would have been to written individual fractions of 15x squared over 5x plus 6x over 5x minus 5y over 5x. If you made the individual fractions, they would all reduce. I could have written dy dx equals to 3x for the first reduction plus 6 over 5 for the second reduction minus y over x for the third reduction. Equally correct. If you like reducing, make the individual fractions. If you want to just live with it not reducing, then make the big fraction. So we have a couple of crazy problems right now where I ask you to find an equation of a line. And I use a derivative that we've done earlier. So in problem 17, 18, 19, 20, I'm supposed to find the equation of a tangent line at a point. And I've already calculated the derivative, and we did this derivative when I did problem 2, so this is the derivative. In order to find an equation of a tangent line, I need a slope and a point. Usually, I only have the x coordinate of the point, but I gave you the full point here because I'm going to need the full point to get the slope of the tangent line. I get slopes of tangent lines by plugging normally just the x into the derivative, but this derivative has both an x and a y, so I'm going to get the slope of my tangent line of plugging 2 in for x into the derivative and 4 into y for the derivative. So my slope, I'm going to use the derivative that I came out. That's the formula for the slope of the tangent line. In the numerator, I'm going to plug in 2 for x. In the denominator, I'm going to plug in 4 for y. I don't know why I use the times sign and not a parentheses. Let me make that a parentheses. So this slope is going to be 8 plus 4 over 8. So my slope is going to be 12 over 8. Reduced by 4, I think, is going to be 3/2. So now I have my slope. Feeling like I have a wrong answer somewheres. Down here, this isn't looking, you can't see my wrong answer. I think, let me make sure I haven't messed up yet. Boy, could I do that derivative in my head. 4x plus 5 over 2y. That's correct. So plugging in 2 for x, getting 8 plus, haha, look at that. That number, I don't know why I randomly changed that. I should have written a 5 there. I started writing a 4. This should be 8 plus 5 because that was supposed to be a 5. So I'm supposed to do 4 times 2 plus 5 over 2 times 4 for the slope. And that's going to be 8 plus 5 over 8. My slope is supposed to be 13 over 8. I have the answer written off screen. so that just these stupid mistakes that I make aren't permanently on my work. So now I have everything I need other than this ugly math. So I'm going to use y minus the y coordinate of the point that was given equals the slope that I calculated using the derivative equals, so slope times x minus the x coordinate of the point. And this is going to be y minus 4. I'm going to emphasize it's 4 over 1. I'm going to need that. And it's 13 over 8x. And then I get 13 over 8 times minus 2. When I multiply the 13 over 8 times the minus 2, the 8 will cancel with the minus 2. I'll go 8 divided by 2 is 4, minus 2 divided by minus 2 is 1. And this will give me minus 13 over 4. So I need to solve for y. I'm going to rewrite this 4 as 4 over 4 to get it to have a decent denominator. So I'm going to rewrite this as y minus 4 over 4 equals 13 over 8x minus 13 over 4. And now I'm going to add 4 over 4 and add 4 over 4 and get y equals to 13 over 8x. And these have opposite signs. I still think I've got an error that you can't see off screen. I get negative 9/4 here. Let me check here. Negative 20, negative 13 over 4 feels right. Adding. This feels right. I'm telling you the answer I have off screen is different. So there could be a mistake here that I'm not seeing. But I'm doing the work in my head and I don't see a mistake. So if there's a mistake, I apologize. I'm not seeing it right now. And I purposely wrote answers that I could check to make sure I'm not writing mistakes on the video. I don't see a mistake. I think I actually have a mistake on my answer. So I'm going to pull that off to the side and check it off video. Problem 20, same deal. It asked me to find an equation of a line, and I have already computed the derivative, so I'm not going to recompute it. So I have a point, and I need a point and a slope to find an equation of a line. To get my slope, I'm going to use my derivative. And in my derivative of 12 times x minus y plus 3 over x, I'm going to plug in 1 for each of the x's and 3 for the y's. This is going to give me what? 12 minus 3 plus 9. And I don't need to write over 1. That's just 1. And this is going to be 18 for the slope. So I have a point of 1, 3 and a slope of 18. And now I'm going to go y minus the y coordinate of the point 3 equals 18 times x minus the x coordinate of the point 1. And then just do the math. I get y minus 3 equals 18x minus 18. And then plus 3 plus 3. And I get y equals 18x minus 15. And I don't have the same answer on my screen again that you can't see. I must have been tired when I was writing these. I feel like this answer is right. Let me check on the slope. 18 feels good there. My math looks as good as it's going to get. I hope I don't have 2 back-to-back mistakes, but if I do, I'll fix the video. Then the last kind of problems that we did in the warm-ups, I'm going to find dr dt, which means each time I take a derivative of a variable, unless it's a t, I tack on the derivative of that variable dt. And I snuck on some pi's here because in the next section we're doing word problems and we're going to have coefficients of pi because we're doing geometry problems and we have like the pi r squared formula for the area of a circle that comes up. And so pi is just like, to find the derivative of this problem, to find the derivative of c equal to 5r is no different than finding the derivative of c equal to pi r. The pi is just a coefficient. So I'm going to do the derivative of each side. The derivative of c would naturally be 1, but I'm taking the derivative with respect to t, and that variable is not a t, so I need to tack on a d that variable, dt. And on the right-hand side, it's a first power term. The derivative of any first power term is its coefficient. In this case, its coefficient is pi. Because I'm taking the derivative with respect to t, and that r is not a t, I tack on d that variable dt. And now I just divide both sides by pi. On the right-hand side, the pi's cancel. On the left-hand side, I don't need to write that 1. I get dc dt over pi equals dr dt. And that's the answer to problem 22. Honestly, I like the dr dt maybe to be written on the opposite side, but I didn't write it there. When I typed the answer up, I have the dr dt on the left side and the dc dt over pi on the right side. Made a big 3-layer fraction there, as opposed to this kind of slanted 3-layered fraction. It doesn't matter. This is fine and that's fine. And dr dt on either side is fine. 24, same thing. I'm taking the derivative with respect to t. The pi is just a constant. On the left-hand side, I'm doing the derivative of a first power term. The derivative of 1a would just be 1. But because I'm taking the derivative with respect to t, and that a is not a t, I need to tack on a dA dt. On the right-hand side, I'm going to go 2 times pi and get 2 pi. Lower the exponent by 1 to r to the first power. And because I'm taking the derivative with respect to t, and that r is not a t, I take the derivative and multiply it by dr dt. Now I divide both sides by 2 pi r. On the left side, I get dA dt over 2 pi r. And on the right side, I get the dr dt, which I was asked to solve for. So my answer to 24 is this, written as a kind of slanted 3-layered fraction with the dr dt on the right, or dr dt on the left, and you can make a big 3-layered fraction, dA dt over 2 pi r. Equally correct, isn't any better. When I'm writing, it's probably just, I don't like the big hunking fractions. Writing a slanted dA dt just made more sense to me. 2 more problems. We're still doing dr dt because that's what we're going to do a lot in the next section. The derivative of v, it's a first power term. The derivative is just its coefficient of 1. Since I'm taking the derivative with respect to t, and that isn't a t, it's a v, I tack on a dv dt. To the right of the equal sign, I go 2 times r and get 4r for the derivative of 2r squared. Because I'm taking the derivative with respect to t, and that's not a t, I tack on a dr dt. And then the derivative of 8 is just 0, so I don't need to write anything for it. Divide both sides by 4r in my efforts to solve for dr dt. And I get dv dt over 4r equals dr dt. And again, I could take the time to write the dr dt on the left side, and I can write this a little bit different, but my answer is definitely not right there. That should be a 4r. 3 mistakes out of like 5 problems. I must have been fatigued when I was writing this. I'll go and fix these so they're not permanently wrong. Last problem. This is a formula that comes up in the next section. So let me do dr dt. The derivative of v, it's a first power term. The derivative is its coefficient of 1. Since I'm doing the derivative with respect to time, or t in this case, t is going to be time in the next section, I tack on a dv dt. And on the right-hand side, when I do the derivative, I multiply the exponent of 3 times the coefficient of 4/3 pi. I lower the exponent by 1. The 3's are going to cancel. And the non-dr dt part is going to be 4 pi r squared. And again, since I'm finding a derivative with respect to t, and the variable here wasn't a t, I tack on a dr dt. And then I divide by 4 pi r squared. Divide by 4 pi r squared. and I get dv dt over 4 pi r squared equals dr dt for a suitable answer to problem 28. And again, you can write the fraction as kind of a 3-layered fraction, and you can write the dr dt on the left. That's probably the more normal way to write it, rather than having the dr dt on the right, which looks kind of unconventional, but it's not incorrect, and it's just how the algebra just came out, and it's okay to leave it like that. So just one more section of new material. It's word problems with this implicit differentiation. This formula is going to come back in. This computation we're going to need on the test. In fact, if you just put this computation into your notes, it'll make the word problems in half of the word problems in section 4.4 way easier, because this is going to be ultimately the formula we're going to use to solve the problems. Let us pause, and we'll move on to 4.4 when you feel ready.